Hey there, this is part 2 of the section 2.4 video on average rate of change. So we're going to continue with another example of the first function, h of t equals t squared minus 1. So now say I want to find the average rate of change from t equals 2 to t equals 2 plus h. And so I made a little graph here. So this is our quadratic, and from 2 to 2 plus h. Now we don't know what h is. H is some other distance away from 2. And so we're still finding the average rate of change is the change in y over the change in x. So we have here the change in x and the change in y. And remember, the change in y is what's also called the net change. So we're going to have the change in y over the change in x, and that is our average rate of change. So, which is really the slope of the line that connects those. So our average rate of change then, as we said before, is f of b minus f of a over b minus a. And in this particular case, our function is h, so it's h of b minus h of a over b minus a. So one of the things that's helpful is to what's b and what's a. So b is the further point, so 2 plus h is b, and 2 would be your a. So plugging it in, we're going to have h of b, right? This becomes then h of 2 plus h. Oh, I just realized this is a bad name for this function. Minus h of 2 all over b minus a. So 2 plus h minus 2. So notice that the 2's will cancel. And so we're just left with h. And hopefully this looks familiar. And it should look familiar because this is actually what we called before the difference quotient back in section 2.1. So I'm going to have h of 2 plus h, so plug it in. So I'm going to have my function is t squared minus 1. So t, everywhere I see a t, we're going to plug in the 2 plus h. So this is going to be 2 plus h squared minus 1 minus h of 2. So plug in the 2. So 2 squared minus 1 all over b minus a. But b minus a reduces to just h all over h. And then simplify this out. So I'm going to change it to parentheses now because the inside parentheses, I'm going to multiply it all out. So I'm going to have 4. So 2 plus h squared is 2 plus h times 2 plus h. Don't forget to FOIL here because you will have middle terms, right? So 2 times 2 is 4. 2 times h is 2h plus another 2 times h. So I'm going to have plus 4h, and then plus h times h is h squared. Be careful not to make the mistake of just saying 4 plus h squared. FOIL so that you get those middle terms. Minus 1. And then minus h of 2. So 2 squared is 4 minus 1, that's 3, all over h. And simplifying some more, combine like terms. On the inside here, 4 minus 1 is 3. So I have 3 plus 4h plus h squared minus 3 all over h. And combining like terms again, 3 minus 3, those cancel. And we're left with 4h plus h squared over h. And I can continue to simplify. Factor out an h from the numerator. So I'm left with 4 plus h divided by h. And now I can cancel that h. H divided by h is 1. And so our final answer, so our average rate of change with this little variable here of h is 4 plus h. And so as h changes, this is going to change. Right, if h was 1, I'm really finding the average rate of change between 2 and 3. If h is 0.5, I'm finding the average rate of change between 2 and 2.5. If h is 0.01, I'm finding the average rate of change between 2 and 2.01. And so as h changes, our rate of change is changing as well. So, and this looks familiar because, again, the average rate of change is the slope of the line that connects the 2 points. And when we did the difference quotient, remember the difference quotient was the slope of a line that connected 2 points as well. So there's the connection. So let's try another example with a slightly more complicated function. So this is my fourth example. So say g of x, let g of x equals 2 over x plus 1. And let's find the average rate of change between, we'll do 2, from 1 to 2, from x equals 1 to x equals 2, and b from x equals 1 to x equals 1 plus h. So we're going to try to practice this difference quotient stuff. So if you want to pause it so you can do part 8 on your own and see how you do, you can do that. So for part A, right, the average rate of change is going to be f of b minus f of a, but this is g, so I'm going to say g of b minus g of a over b minus a. So in this case, I'm going from 1 to 2, so it's going to be g of 2 minus g of 1, so this is the net change, divided by 2 minus 1. So remember again, that change in the y is your net change. So what's g of 2? G of 2 becomes, plug it in, right? My function is 2 over x plus 1, so when I plug in 2 in there, we're going to get 2 over 2 plus 1 minus 2 over, plug in 1. G of 1 is 2 over 1 plus 1, all over 1. And so when we simplify this, we get 2 over 3 minus 2 over 2, which is 1, all over 1. So the nice thing about having 1 on the bottom is that I just get the numerator. And so getting a common denominator here is 2/3 minus this. You can write it as 1 over 1. So common denominator is 3, so minus 3 over 3, which is negative 1/3. So the rate of change for this particular function is negative 1/3, right, from x equals 1 to x equals 2. So the average rate of change is negative 1/3. So negative means that it's decreasing. So the function was decreasing during that time. And if you take a look at the graph of the function, so our f of x is 2 over x plus 1. And I don't expect you to necessarily know the graph of this function. In fact, in this class, we're going to learn how to graph them. But just from, I'm just going to draw it for you real quick. So when this function, this has a vertical asymptote at negative 1. And so, and it comes down like this. And so when we're looking at the interval from 1 to 2, notice that the function is decreasing. And so it does make sense that the average rate of change then will be negative. Remember, this is essentially the slope of a line that would connect these 2 points. And so the slope of that line, notice that it is negative. And so that makes sense. So in this particular case, right, this function is always decreasing. So because it's always decreasing, any slope here is going to be negative. And the other side of this graph, it looks like this. So this function is actually always decreasing. So the average rate of change, we should expect it to be negative. If a function is always increasing, then we should expect the average rate of change to be positive for an increasing function. Now, if it changes from increasing to decreasing or decreasing to increasing, we might see different things. Sometimes it could be positive, it could be negative. But if it's always decreasing, then we should expect to see the average rate of change to be negative. If it's always increasing, we should expect the average rate of change to be positive. Okay, so part B is the average rate of change between x equals 1, so from 1 to, 1 plus h. So in this case, the average rate of change is going to be g of b minus g of a. So g of 1 plus h minus g of 1 over b minus a, 1 plus h minus 1. So notice that the 1's cancel, and so we're left with this difference quotient type thing, g of 1 plus h minus g of 1 over h. So let's plug it in. Our function, just to write it again, g of x was 2 over x plus 1. So in this case, I'm going to have g of 1 plus h. So this is where things get a little crazy. So I'm going to have 2 over, everywhere I see an x, right, I replace it with 1 plus h. Remember, the input here is x. So what you're doing to the input, as you change it, you plug it in. So it's 2 divided by the input plus 1. So my input is 1 plus h. So I'm going to have 2 over the input, 1 plus h, plus 1, minus g of 1. G of 1 is 2 over the input, which is 1 plus 1, divided by h, as we did it here. So then we have 2 over 2 plus h, combine like terms, right? 1 plus 1 is 2, and this is minus 1 over h. So common denominator is 2 plus h, so that means this one needs to be multiplied by 2 plus h on the top and the bottom. I put a 1 under there so that you know it's a whole number, is still a fraction if you just put a 1 under it. So I'm going to have the same denominator of 2 plus h, the whole thing divided by h, right? I have this and the 2 minus, and when I multiply this, 1 times 2 plus h is just 2 plus h. I'm using parentheses so I don't forget to distribute my negative. So now this becomes 2 minus 2 minus h as I distribute this negative over 2 plus h and the whole thing over h. And this is where I'm going to say, okay, h over 1, so that I can multiply by the reciprocal. And the nice thing that happens here is that my 2's cancel. 2 minus 2 is 0. So what are we left with? Negative h over 2 plus h. Right? That's my top function, is negative h over 2 plus h. But then I have divided by this guy. So divided by h over 1 is the same thing as multiplying by 1 over h. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. And now I can cancel h divided by h is 1. So we're left with negative 1 over 2 plus h. So the average rate of change in this case is negative 1 over 2 plus h. So notice that we also get a negative slope. So that means that this function must be decreasing on that interval from 1 to 1 plus h. And so if you have a graphing calculator, you could try to graph what 2 over x plus 1 looks like and see what the function is doing around 1. But it appears that it will be decreasing. So that's our average rate of change.